Plates coming together. Andes Mountains and the Aleutian Island Arc. So we're going to have a look at converging boundaries where plates come together, and depending on what type of plates are colliding or coming together and the crustal formations that happen there. So there is a video on the Andes Mountain Range in South America and a video on Alaska and the Aleutian Island Arc. Today we're going to relate plate tectonics to the crustal feature formations. So, a subduction zone and volcanoes. At some convergent boundaries, an oceanic plate collides with a continental plate. Let's look at the image. Here you have an oceanic plate colliding with a continental plate. The oceanic plate tends to be a denser, thinner continental crust, so the denser oceanic crust gets bent and pulled under or subducted beneath the lighter and thicker continental crust. So when the oceanic crust collides with the continental crust, it subducts, it gets bent, it's more dense, it gets bent underneath that continental crust. This forms what is called a subduction zone. As the oceanic crust sinks, a deep ocean trench or valley is formed at the edge of the continent. So here you can see the oceanic plate subducting and melting in the mantle. This forms a trench off of the continent, which is a deep depression in the ocean. The crust continues to be forced deeper into the earth, where high heats and pressure cause trapped water and other gases to be released from it. This in turn makes the base of the crust melt, forming magma, and then that magma is pushed up and it forms volcanoes or volcanic mountain ranges on the continent. A subduction zone. A subduction zone is also generated when two oceanic plates collide. So you have one oceanic crust colliding with another oceanic crust. The older plate is forced under the younger one, and it leads to the formation of chains of volcanic islands known as island arcs. So looking here, we have an older, denser oceanic plate. It's subducting underneath the younger oceanic plate. This is forming deep depressions called trenches in the ocean. And when that older crust sinks or subducts underneath the younger one, it melts inside the asthenosphere. Magma is pushed up, forming volcanic island arcs in the ocean. Some examples include the Mariana Islands in the western Pacific Ocean and the Aleutian Islands off the coast of Alaska. So, in summary of a convergent boundary, it's the boundary between two colliding tectonic plates, and the crustal formations depend on the type of plates that are converging. So if we look at continental crusts converging or coming together, they push up and they form folded mountains, like the Himalaya Mountains. If we have a continental oceanic plate converging, coming together, the oceanic plate is going to subduct underneath the continental because it's more dense. We're going to get volcanoes off of the coast of the continent, like the Andes Mountains, and trenches off the coast as well. If we have an oceanic plates converging or colliding, the older oceanic plate subducts, melts in the mantle, and forms island arcs in the ocean as well as trenches. Some examples would be the Aleutian Islands off of Alaska. So, give me three summarization. What's a first fact, a second fact, a third fact from the reading or the videos above? So you can type that in here. The first fact from the reading or videos are, second fact, and third fact. Next, we're going to analyze these maps. These are maps of the Andes Mountains in South America. So here you can see along the coast of the continent, you see lots of earthquakes here. Here is the plate boundary. This would be your oceanic plate and continental plate coming together at this plate boundary. Here you're seeing the plate motion and the topography. So you have the oceanic plate subducting underneath that continental plate. Okay, and here we see volcanoes and some satellite and seafloor images. So we're only going to analyze the map above about South America and the Andes Mountains, and from the reading and also the video we can draw some conclusions about that. So the Andes Mountains, we're looking at a plate boundary where we have an oceanic plate converging with a continental plate. The process that happens here is subduction. The oceanic plate subducts underneath the continental plate, melts in the mantle, and makes volcanoes. Well, your geological formation, that's what you would put here, are volcanoes or volcanic mountains, as well as trenches off the coast. You're always going to get trenches at ocean boundaries. Now we're going to analyze some maps on the Aleutian Islands in Alaska. So here, all along where these dots are, we're seeing earthquakes. Here we have a plate boundary of an oceanic plate and another oceanic plate converging. And here we see that motion with our topographic map, we'll have putting the arrows there. Volcanoes, those are going to be the volcanic island arcs. Okay. Now, analyzing the maps of the Aleutian Islands, we're going to use the reading and the videos to draw valid conclusions about the geological features. So the type of crust we have here is an oceanic converging. The process is subduction again. You're going to have the older oceanic plate subduct underneath the younger one. It's going to melt in the mantle, and then for your crustal formations, that magma is going to be pushed up on the ocean floor, forming volcanic island arcs like the Aleutian Islands. You're also going to get trenches. Again, trenches are found at any boundary that involves the ocean. For our connection today, we're going to look at a STAR test question. It reads, a mid-ocean ridge separates the Pacific plate and the Nazca plate off the western coast of South America. So here we can see South America, we have the Nazca plate and the Pacific plate, and here's the boundary. It's a crustal formation of a mid-ocean ridge here. Describe the relative motions of the Pacific and the Nazca plate using the compass. So using this compass, we can see, understanding from a mid-ocean ridge, this is a divergent boundary where these plates are moving away from each other. So we can say the Pacific plate is going to be moving west, where the Nazca plate is going to be moving east, because this is a divergent boundary where they divide. They go in opposite directions. So what forms there? You're going to get volcanoes, underwater mountains, even the mid-ocean ridge. For the exit today, based on the map, volcanic activity would most likely be found at what location? W, Y, Z, and X. So if you're analyzing area W, you can see there's no boundary there. We understand that volcanic activity is always going to happen at a boundary. Here, this is just on North America plate. There's no boundary here. But Z is actually located at this dotted line where it's telling you it's a converging boundary. So we know that plates are coming together. The oceanic plate is going to subduct underneath the continental plate. So we're going to get volcanic mountains there. Okay, and X, location X behind here, that's not located on a boundary. So you want to make sure you're looking at your key and the placement of these letters. Okay, the Z would be the best choice because not only is it on a boundary, but converging boundaries. And we know we can find volcanic activity at a converging boundary.